Hello students, myself Ambrish, physics lecturer. You have studied the chapters in track 1. Actually in physics there are two tracks, track 1 and track 2. In track 1 you have studied chapters like physical world and units and dimension, motion in a straight line. Now you are studying motion in a plane, it seems. So I will teach track 2. Track 2 means in that track 2 the first chapter will comes, that is called mechanical properties of solids. Okay. Mechanical properties of solids, or we can say actually this will come in general properties of matter. Okay. Under general properties of matter, the first chapter will comes mechanical properties of solids, and the next chapter is mechanical properties of fluids. We have studied some basic difference in class 10th and 9th about solids, liquids and gases, right? So in solids what happens? The atoms or molecules are closely packed together. There is no space between atoms, whereas in liquids the space is much larger comparing to the solids, and whereas in gases the distance between atoms or molecules what happens means that is very large. The space is very large comparing to these solids and liquids. Like that we can differentiate solids, liquids and gases. And also you know some other differences like solids have definite size and shape, liquid have definite volume but not definite shape, isn't it? And like gas means it doesn't have definite size or shape. Okay. And if you talk about energies, kinetic energies, that is in solids it is having least energy, and in liquids it's still more than solids, and in gases it's having very high energy comparing to the solids and liquids. These are the basic differences what you have studied in previous classes, right? Here mechanical properties of solids. In mechanical properties of solids what we will study means first of all what is mechanical property means. This is also called physical properties. Physical properties, we will study about the physical properties like ductile, okay, ductile, elasticity and malleability. So what are these means? These are the properties. One by one I will explain in this class. We will going to study about these physical properties under application of force, different form of force. So if you have apply a different form of force on the solids, we will study how it will behave. Or if you apply a large force on the solids, how the properties will perform. About those we will study in this class, that is under mechanical properties of solids. So to understand this chapter you should know the basic reason or basic cause for all these properties. In solids we have ductile, elasticity, malleability. If it comes to fluids there are some other properties like surface tension, viscosity. Okay, for all the properties of matter the basic cause, the basic reason is intermolecular force or interatomic force. First we have to know about what is intermolecular force or what is interatomic force. So to understand that concept, let us consider these are the atoms or molecules in a substance. Okay, these are the atoms or molecules in a substance, and between all the atoms there exists a force. That force is called interatomic force. Or if you consider molecules, between the molecules there exists a force. That force is called as intermolecular force. So if you consider this atom, on this atom in all direction there will be a force. How to imagine that interatomic force or intermolecular force means, let us consider these atoms are connected by a spring. Okay, for consider, that means to understand this concept, let us imagine each and every atoms are connected by a spring, right? So like this, each and every atom is connected, and you know the working of spring. That is, if you consider this is a spring, the spring is connected between these atoms. At equilibrium or initially when no force is acting on these atoms, it is having some distance, the distance between two atoms. That distance let us consider as R0. This is interatomic distance. So here also let us consider when no force is acting, the distance between the atom, I said R0, no. Now let us imagine if we apply force on this spring in this direction, that is elongative force, then what happens? Definitely if you stretch the spring, the distance will increases. After applying the force, the distance will increases, right? So this is the previous distance before applying the force. After applying the force, this is the new distance between two atoms. Let us take that the distance is r. Definitely we can say that this r distance is greater than r0. This is one condition, right? And next condition, this is the initial distance between atom, and what you will do, the initial distance we have mentioned R0, right? What you will do means you will apply force in this direction, inward. Due to this force, definitely what you will observe means the spring will compress. The spring will compress and the distance, let us take it as R. Now this distance is less than R0. Okay, so two possibilities I am explaining. So in this substance, these are the atoms. If we have apply force on these atoms, the distance between atoms may increase, or if you apply force such that the distance between atom may decrease. The two possibilities I have shown here. You can imagine like a spring. Then if the distance between the spring increases, then what happens here? Definitely a force will develop in the spring, right? So in which direction? So this is after applying force, right? So if we leave, you stretch the spring and you leave, the spring will takes the initial position. That means the force will develop inside the ring in this direction. What type of force we can say this is? This is an attractive force. And you compress the spring, then what happens means as soon as you leave that spring, again it will go back to their initial position. That means in that case, what type of force will develop means that force we can say that is repulsive force. So the similar way we can imagine in this diagram also. If the between the atoms, the distance, the interatomic distance or intermolecular distance increases means to regain its position, it develops a force. So that force is in attractive, that force is in attractive nature. And if the distance between atoms or molecules decreases means then also the force will develop, and that force is in repulsive nature. So two types of forces develops between atoms or molecule depending upon their position. Okay, that force name is attractive force and repulsive forces, and you can that means you have understood when attractive force will develop and when repulsive force will develop. So we can give the statement like the force between atoms or molecules are called interatomic forces or intermolecular forces. Right, this force is responsible for so many properties of matter, like what I said, the properties ductility, malleability, elasticity. Okay, so this is the basic concept we have to understand before entering into the mechanical properties of solids. So under this chapter, once again I will tell what we will study, what you will study, that is by application of large forces, how the properties will behave, or how the properties will perform. About those concepts we will study under this chapter. So note down these diagrams. So in the diagram you have to imagine that the spring is connected between two atoms, like that you have to imagine, then you can understand what type of forces will develop. And very first, in mechanical properties of solids, you should know about the definition of rigid body. What is a rigid body? That means if you apply a large force also, the size and shape of the body does not change. Such type of a body is called a rigid body. If you consider this body, if I apply force, it breaks. Okay, these type of substance we cannot consider as a rigid bodies. So let us consider the ceiling, okay, or the roof. If you apply even a large force, then the size and shape does not change. So these walls, these roofs, these type of bodies we can consider as a rigid body. Definitely if we want means we can break everything, but here a rigid body concept means even a large force also it will withstand. Such type of a bodies are called as a rigid body. So note down the definition here. I will write: the body does not change its size and shape even though large forces applied. Okay, that bodies are called as rigid bodies. After understanding this rigid body in this chapter, next what you have to understand means a special property of the matter called elasticity. Okay, a special property of the matter called elasticity. So to understand this elasticity concept, let us consider a rigid body. So this is let us consider a ceiling. From the ceiling we have suspended a iron rod or steel rod. Okay, a steel rod is suspended from this ceiling. This is what? Rigid body. And this steel rod is having length, its initial length that length, let us take it as L. Then what we will do for this steel rod, we will attach some load. Here we will attach some load. Okay. So before attaching the load, the length was L. If I attach a load, what happens means, due to gravity, mg, the weight will act vertically downwards. That means the force will act downward direction. For example, let us consider how much force is acting downward direction means 1 Newton. Okay. By adding this weight, 1 Newton is acting vertically downwards. Because of this weight, the length of the wire is, previously this was the original length. Because of this force, the length of the wire is increased. Okay. That means it changes its size, it changes its length. Whichever force will changes the size and shape of the body, right? The force which changes the size and shape of the body, that force is called as deforming force. What is deforming force means? The force which changes size and shape of the body, that force is called as deforming force. That means here I said the force is acting vertically downwards means what type of force is acting vertically downwards? The force name is deforming force. So how much length was increased means, let us consider the length is increased by 1 millimeter. The length of the wire or rod is 1 meter. After adding 1 Newton, the length is increased by 1 millimeter. Now what I will do, I will remove the load. That means you can imagine the atoms or molecules in this rod. After adding the weight, definitely due to the application of force, the distance between atoms will increases. The distance between atom will increases means the intermolecular force will develop inside this rod. Okay. If the distance will increases means definitely you know that attractive force will develop between these atoms or molecules. And as soon as we will remove the load, again the atoms tries to regain its original distance, because an attractive force is developed between the atoms. So that force is not outside, that force is inside. Due to that force, suppose the rod regains its original length. If we had a 1 Newton weight, that means 1 Newton force in downward direction, the length is increased by 1 millimeter. If you remove that load, again it will regain its original length. Again the length becomes 1 meter. So this property of the matter is called as elasticity, and the force will develop inside the rod or inside the material due to application of deforming force, right? That force is called as restoring force. Okay. Here elasticity means how we can define it is a property by virtue of its it regains its original size and shape. It regains its original size and shape. It's called as elasticity. Example: steel, rubber, etc. Okay. So once again I will tell the elastic property. Let us consider this is a rod. We will add some load to this rod. Then what happens means the length will increases. Because of the increase, that way why the length will increases means the distance between atoms present in this rod also increases. So when the distance changes between atoms or molecules, the force will develops, right? So that force develops inside the rod. As soon as you remove the load, again the atoms tries to regain its original distance between them. Because of that, it will regain its original length. So that property of matter is called as elasticity. After removal of deforming force, it will regain its original size and shape. Gains original size and shape after removal of deforming force. So note down these definition: rigid body and elasticity. Then what is meant by plasticity? Plasticity means you apply force. If the size and shape will changes means after changing the size and shape, it doesn't regain. That type of property of a material is called as plasticity. Elasticity and plasticity are properties of matter. It is not a material names. So if the size and shape is regained after removing force, that property is elasticity. If size and shape doesn't regain means that property is called plasticity. Here I will write the definition of plasticity. It is a property by virtue of its it does not regain the original size and shape after removal of deforming force. Okay, that property is called as plasticity. Which example you can give for plasticity means chewing gum and putty. Okay, it's a type of mud. So you can give these example for plasticity. On chewing gum you apply force. After you remove that force, the chewing gum does not regain its original size and shape. So such type of properties of a matter is called as plasticity. I hope you understood what is meant by elasticity and what is meant by plasticity, and what is deforming force, what is rigid body. And next in this chapter you should know the definition of stress. Okay, what is meant by stress? That means here once again I will take the same example. It is having 1 meter length, right? So before, that is 1 meter before applying the load. After applying the load, I will add 1 Newton to this hanger. Okay, then what we used to see means the length of the rod is increased. How much it is increased means 1 millimeter. Okay, then I will add one more load. Now the force acting downward is, let us consider 2 Newton. Then the length also increased by 1 meter. Now the change in length, that is the length increased is how much? 2 millimeter, right? So here if you remove two loads, you know that it regains again 1 meter length. Why? Because a force is developed inside the rod. That force is due to intermolecule, and the name of that force is called restoring force. That means a deforming force is acting downward, a restoring force will develop that will act in opposite direction to deforming force. Then what is the magnitude of restoring force? Deforming force is 2 Newton acting downwards. Now it is at equilibrium, there is no movement of the length, or the length is not further increasing. At equilibrium, the 2 Newton is acting downward, means as soon you remove that 2 loads, again it will regains its original length, means definitely 2 Newton force should act in upward direction. In numericals, sometimes they won't give the restoring force value. You have to understand that deforming force value is equal to restoring force. So in magnitude wise, deforming force is equal to restoring force, but the directions are opposite. This is we are applying, this is creating inside the material. Okay. And what is stress means? Stress is defined as, it is the ratio of restoring, it is the ratio of restoring force by unit area, restoring force to the unit area. This is called as stress, and this is equals to, we can write F divided by A. Now stress is equals to F by A. Can you tell me the units here? What is the SI unit of force? SI unit of force is Newton. What is the SI unit of area? Area is meter square, that means Newton per meter square. SI unit of stress is, SI unit of stress is Newton per meter square. And what is its dimensional formula? Dimensional formula for Newton is mLT to the power minus 2. And what is the dimensional formula for meter square? That is L to the power minus 2. Okay, then we can write dimensional formula for stress, M, L, minus 2 here, 1 here, so it will become minus 1 T to the power minus 2. So remember, this is the dimensional formula for stress, and this is the SI unit of pressure, or you can say one more name, that is Pascal. Okay, Pascal is also a SI unit of stress. How to measure, how to define stress means, it is restoring force per unit area. So note down. Okay, so this is about stress, and next you should know there are 3 types in the stress, that is, I will write the heading, types of stress, types of stress. First one is normal. First one is normal stress. What is meant by normal stress? Let us consider a body or a block. On this block, this is the direction of the force. Okay. On the surface, what is the angle made by this force. Definitely the angle made by this force, you can see that 90 degree. Making 90 degree with the surface, that force per unit area, that is called as normal stress. Okay, normal stress is defined as normal, I'll rub this one. Normal stress is defined as normal restoring force per unit area. This is called as normal stress. And if you have a rod, okay, if you have a rod, to this rod, if you apply the force in this direction, an elongative force, so definitely the length of the rod will increases, right? The length of the rod will increases. So this type of stress is called as longitudinal stress. In longitudinal stress, if length increases means that stress is called as tensile stress. Okay, this longitudinal stress is also a normal stress. Suppose due to the application of force the length increases means that stress is called as tensile stress. Or if you apply the force in this direction, then what you will observe means the length of the rod will decreases. Suppose if the length of the rod decreases after applying the force means the stress developed in the rod, that name is called as compressive. That name is called as compressive stress. You understood what is meant by stress, restoring force per unit area. In that stress, this is one type, that is called normal stress. That means the force making angle 90 degree with the surface, that is called as normal stress. In normal stress, again we define longitudinal stress. Longitudinal stress means we will apply force on this rod. Because of that force, the length increases means that is called tensile stress. If you apply force, if the length decreases means that stress name is called as compressive stress. And next one is volumetric. Okay, next one is volumetric stress. So what is meant by volumetric stress means if the force is applying to entire volume, if the force is applying to entire volume, then the restoring force per unit area is called as volumetric stress. For example, let us consider a rubber ball is placed in a liquid. Then what you will observe means the liquid will apply pressure, that means force on the entire volume of the ball. The stress will develop inside that ball. That stress is called as volumetric stress. Okay, again the force applying on the volume, again it makes 90 degree with the surface. So this longitudinal stress or volumetric stress is nothing but a normal stress. Okay. And second type of stress is there. Normal stress means what I said. So this is the body means the force acting perpendicular to the surface. The type of stress is called as normal. Then one more type of stress, that is called as shearing or tangential, shearing or tangential stress. Okay. So this is defined as tangential restoring force per unit area. Then what is shearing or what is tangential stress means? If you consider this body, suppose if you apply force in this direction, okay, if you are applying force in this direction means what is the angle between the surface and this force? Definitely the angle between the surface and force is 0 degree, right? Here what is the angle between surface and force? Here definitely the angle is 90 degree, right? So this type of force is this type of force per unit area is normal stress. So this type of force per unit area is called as shearing or tangential stress, and that is defined as tangential restoring force per unit area. These are the different types of stress. Okay, one is normal and another one is shearing. Note down. So these are the basic definition which comes under this chapter. And next, which definition you have to understand means you have came to know what is stress and types of stress. And next one is you should know about what is meant by strain. Okay. So stress means for this rod, if you attach any load, then we can say the rod or the wire is under stress, and it is defined by restoring force developed per unit area. Because of that restoring, that means because of this load, because of this deforming force, what we used to see means the length of the rod will increases. Okay, this is the original length L, and this is additional length because of this load. That length is delta L, change in length. And the strain is defined as, basic definition of strain is change in dimension, change in dimension to the original, change in dimension to the original dimension, and it doesn't have any units or dimensional formula. Why? Because in numerator and denominator both units will same and it will get cancel, so it doesn't have any units or dimension. For 1 marks, if they ask which is the unit and dimensionless quantity means, you can say that strain is unitless and dimensionless quantity. And here this type of strain is defined as longitudinal strain. The stress is longitudinal stress, right? Then the strain is longitudinal strain. How to define the longitudinal strain here? Longitudinal strain is defined as change in dimension. Here length, the length is changing, change in length divided by its original length, right? So this is called as longitudinal strain, change in length per original length. And next one is volumetric volumetric strain. So what is meant by volumetric strain? I said one example, consider a rubber ball. Okay, this rubber ball is placed in a water or a liquid. Definitely it experiences a force in entire direction. Okay, in all the direction the force will act on this rubber ball. At any point you can see it is making an angle 90 degree with the surface. At this point also you can see 90 degree, at every point you can see 90 degree. That means the stress developed the stress developed inside the ball is normal stress, right? And volumetric stress is also a normal stress. So because of this force on the entire ball, the volume of the ball will decreases. This is the original volume. Now you consider this is the present volume due to application of this force or pressure on this ball. Then volumetric strain is defined as change in volume delta V divided by original volume. Original volume is V, the change in volume is delta V. This is called as volumetric strain. In some textbook they will give minus sign. Minus sign indicates decrease in volume. This is how we can define longitudinal strain and volumetric strain. And next one is shearing. Shearing strain. Okay. So how to define this shearing strain? Shearing strain, to understand the shearing strain, let us consider a block. If you consider this block, what type of force we have to apply? Tangential force. Tangential restoring force per area is called tangential stress. In this direction we are applying force, tangential force. This block, consider a large size book. Okay, that large size book placed on a table, like that this block is placed on the table and you apply a tangential force on the top surface. Then what you used to see means the bottom surface does not move. It will this point is fixed here only, but the top surface, the top layer will displace relative to bottom layer. You will see somewhat like this. Okay, this is the new shape after applying the shearing stress or tangential stress. Then how to define the shearing strain means, you can see this angle, it is creating some angle theta, and between this point and this point, let us consider the distance is delta x, and this length, the length of the block, let us consider it as L. Okay, and the shearing strain is defined as theta. Theta is equals to, how to define theta? Normal definition, arc upon length, right? Here also the same method, delta x by L. This is how we define shearing strain. In definition, that means in words, how to define a shearing strain means, this delta x, okay, this delta x is relative displacement between two extreme layers. Okay, relative displacement between two extreme layers by the length of this object or length of the block. This is the definition of shearing strain. And remember, this normal stress, in a normal stress, again I explained longitudinal stress. In longitudinal stress, again you came to know the meaning of tensile and one more is what? Compressive. Tensile stress and compressive stress. And one more stress I explained, volumetric stress. Volumetric stress is also called as one more word. Volumetric stress is also called as bulk stress. Okay. So due to that stress, the size of the object will changes. It does not affect the shape. But this tangential or shearing stress, what we will apply a tangential force on the object, because of that stress, the shape will changes. To change the shape, tangential stress is responsible, remember. So this is about some definition of rigid body and deforming force and elasticity, plasticity, then stress, types of stress and strain, types of strain. In the strain, longitudinal strain, volumetric strain and shearing strain. Okay.